Today I'm going to talk about this project, which is the atomic structure. My learning objective is the distribution of electrons in an atom, which fulfills the big idea 1. Now I'll be talking about my 3D model, which is the Bohr's atomic model to fulfill the science practice 1. We know that atoms are composed of electrons, protons, and neutrons. In this model, the yellow beads represents the electrons. The nucleus is in the center and surrounded by well-spread spaced orbitals, which are the blue circles. The letters K, L, M, and N represents the energy level. We can see that the smaller of the number of electrons, the closer the energy level is to the nucleus. The formula 2n squared is used to predict the maximum number of electrons in the energy level. This is an example of Bohr's model of oxygen. In order to make the Bohr's model of oxygen, we need to know how many protons, neutrons, and electrons are in an atom of oxygen. We know that our oxygen has an atomic number of 8 and an atomic mass of 16. To find the neutrons, we subtract the atomic number from the mass number. Because oxygen has 8 electrons, it has 6 valence electrons in the outermost shell, which is represented by the green beads. Now I'm going to conduct an experiment which fulfills my science practice 3. In order to conduct this experiment, I drew 5 circles. I marked the center of the circle with a large dot which represented the nucleus of the atom. I counted 100 dried beans and put them in the funnel. Now I allow the beans to fall through the funnel onto the paper target. We can see that most of the beans are further away from the nucleus. Also, the beans' distance from the nucleus in terms of other beans varied. From the data, we can see that in ring 2 there are 53 beans and in ring 5 there are 5 beans. In this experiment, the beans represented by the negatively charged electrons in an atom. It was not possible to determine the exact path of the electrons in an atom. This is because electrons has a dual nature. It acts as a wave and also as a particle, so the exact path of the wave cannot be determined. This finding relates to the quantum theory of Erwin Schrödinger. Schrödinger's wave equation resulted in specific orbitals. Orbitals are regions that describe the distribution of electrons' densities. Electrons fill the orbital according to the pattern. This is an electronic configuration of oxygen. Oxygen has an atomic number of 8, so it fills up 2 energy levels by using the Hund's rule and the alpha-blue principle. So the electron configuration of oxygen is 1s squared, 2s squared, and 2p to the power 4. The solution to the Schrödinger's equation are characterized by 4 quantum numbers. Now I'm going to find the quantum numbers of oxygen, which will satisfy my science practice 2 and my learning objective distribution of electrons in an atom. We know that oxygen has an atomic number of 8, so its electron configuration is 1s squared, 2s squared, and 2p to the power 4. It fills up 2 energy levels. The principal energy for oxygen, which is represented by the letter N, is 2. The angular momentum quantum number, which is represented by the letter L, is 1. Since it is in the p sublevel, we can see in the table that the angular momentum for p sublevel is always 1. The magnetic quantum number, which is represented by mL, is in negative 1. The spin quantum number is negative half since there is a spin in the px orbital. So there are 2 models of atomic structure in use, which is the Bohr model and the quantum mechanical model. Electrons orbit the nucleus in circles called energy levels, and inside the energy levels are sublevels. Inside the sublevels are orbitals. Thank you.